Welcome to my presentation. In this presentation, we shall see examples using properties of logarithms. Okay, so let us say we want to solve a logarithm expression which is of this type: log x plus 4 to the base 5 minus log x to the base 5 is equal to 2. Okay, so if this is what we have, we want to solve for x. So let us write these different steps and then see if we can arrive at the answer in a logical manner. We know that the product rule or the quotient rule is quotient rule which is telling us that log x over y to the base b is going to be equal to log x to the base b minus log y to the base b. Okay, so if we have log x over y to the base b, we can expand it that way, or if we have log x to the base b minus log y to the base b, we can shrink it into that form. Since we have the given expression resembles the right side expanded part of it, so we're going to shrink it into this form. So we're going to write that as log x plus 4 divided by x, this whole expression to the base 5 is equal to 2. Right? Now, once we have that, we'll write the second step as, we know that we can expand a logarithm as an exponent. So if we have log x to the base b is equal to y, we can express a logarithm as an exponent as follows, isn't it? X is equal to b to the power of y. So in here we can express this one as x plus 4 divided by x is going to be equal to 5 to the power of 2, like that. And therefore we can write this as x plus 4 divided by x is going to be equal to 5 to the power of 2, means 5 times 5, which is 25 divided by 1. We can think about it that way as well. And therefore we can simplify this expression some more, and if as you can see in the ratios and proportions, we have seen that if we have a ratio a over b and that is equal to another ratio c over d, we can cross multiply these terms and then write it out as follows: a times d is equal to b times c, and if any one of these quantities is an unknown quantity, we can go find that, and then we will apply that in this particular problem. We will cross multiply this. X plus 4, 1 times x plus 4 is equal to 25 times x. So when we distribute this, 1 times x is x, 1 times 4 is 4, so therefore x plus 4 is equal to 25x. We want to find the value of x. So we're going to subtract x on both sides. So when we subtract x on both sides, negative x plus 4 is equal to 25 minus x. We are subtracting x on both sides. And when we do that, the positive x and negative x cancels out, leaving us with 4 is equal to 25. This should be 25x. 25x minus 1x will be 24x. This is going to be equal to 24x. Since we want to find the value of x, we're going to divide by 24 on both sides. We're going to divide by 24 on both sides, and when we do that, the 24 on the numerator and denominator cancels out, leaving us with x as equal to 4 over 24. 24 is a multiples of 4. 4 times 1 is 4. 4 times 6 is 24. Therefore the value of x is going to be equal to 1 over 6. And therefore we found the value of x. We solved this logarithm expression and we were able to find the value of x as equal to 1 over 6. In my next presentation, we shall see more examples using properties of logarithms.